Hello everyone. Today we are going to do lesson 9-5 variations. As you remember, in rational functions unit we talk about how to graph rational functions, how to find its features like domain, range, intercepts, asymptotes, and behaviors, all those kind of things. Today we are going to do more variation. It's a little bit different lesson this time, but still somehow related to the rational functions. We'll talk about three new concepts: direct variation, joint variation, and inverse variation, and we'll see how we can relate them to the real life. Alright, let's start. What a direct variation means: y as the quantity and x is the other quantity here. Y varies directly as x if there is some non-zero constant k such that y is equal to kx. It's like that, you have two quantities, right? Y and x. So direct variation, if you see there is a change in the quantity of y increasing, and also there is a proportional change increasing on the x, or the other way around. While there is a decrease in the y, at the same time there is a decrease in the x, we can tell these two variables are directly related to each other. So one is increasing, the other one is increasing, or one is decreasing, the other one is decreasing. That's called direct variation, direct relation. Okay, so we show such relations as in this form: y is equal to k times x, where k is the constant here. We'll show it as constant, like this one. Alright, so if we try to rewrite this one in terms of k, that is y over x. K is a fixed number, like as you can see from here. Y is increasing, x is increasing. Y is decreasing, x is decreasing. For example, let's say you have a ratio of 2 to 1. You can definitely make it a 4 to 2, right? And that also can be 6 to 3. Also can be 8 to 4. As you can see, y's are increasing, right, this way. 2, 4, 6, 8, and x are increasing in the same proportion. Or the other way around. Y's are decreasing, x's are decreasing in the same proportion. So if we can see a relation like that, we will call it direct variation. And the formula is this: y is equal to kx. Or you will see us working on k is equal to yx, y or x more. This is gonna be, these two will be the same. We will use any of them to solve the given questions. Alright, k is equal to y or x, or y is equal to k times x. So joint variation is the same thing actually. It's the direct variation still. But this time if you have variables more than 2, you see how we have y and x in the first one, and now if we have z in the third one, or even more, multiple variables, we will call it joint variation. It's going to be the same idea. Like, again, y is equal to kx in the first one, right? This time, since we have z, we will say it is y is equal to kxz. Or if we write it in the constant form, k will be equal to y over x times z. That will use this more during the questions, okay? That's the thing. So, direct variations idea: one variable increasing, the other one is increasing. One variable decreasing, the other one is also decreasing. If we can catch a relation like that, we'll call it direct variation. Okay, so this is the idea. So let's see the first question on page 487. It says y varies directly as x, and when y is negative 3, looks like x is 24. And what is y when x is negative 16? Remember, if it says direct variation, we said that we can use y is equal to kx, or the other one that we will use more, k is equal to y over x. Which means any ratio between the first quantities as y1 over x1 should be equal to the second numbers of the quantities y2 of x2. That's the idea, the ratio. Okay, so this is what we will do, nothing else. Y is negative 3 for the first number, for the first quantity, that is y negative 3 over when x is equal to 24. Okay, this should be equal to the y2 of x2, which is the second number of y which we were looking for, over the second number for x, that's negative 16. That's it. We are just creating a basic proportion here based on the formula we have. Okay, so we'll just do the math. You know how to do cross multiplication. -3 times -16 will give you that. Should be equal to 24 times y. If you solve for y, you know what to do. -3 times -48 is 16 is positive 48. That's gonna be divided by 24. You get y is equal to 2, or 2 is equal to y is equal to 2, doesn't matter. So that means when y is 2, x should be -16 in this proportion. Okay, so that's how we will solve the questions. That's example 1. Let's turn to page 488. We have example 2. Let's see what we can do for it. Suppose y varies jointly. Remember, jointly means you will have more than 2 variables here. Y varies jointly as x and z. So remember the formula we had. K, the constant, should be y over x times z. That was in the first page. Remember, jointly we are using this way. Okay, on the first slide. So y is equal to xz. So since we are comparing the first numbers of the 3 quantities here, it should be like that. K is equal to the first number of y over the first number of x and the first number of z. Should be equal to y2, the second number of y, over the second number of x times the second number of z. That's it. We'll just put the numbers here in the correct spot, and that's it. Alright, find y. Looks like we are looking for y. Okay, so I will say just y, or y1, however you say, over x1, that's the first number, here is 4, and z is -3 here. It should be equal to the second numbers of each this time. We have y is equal to -15 over -6 times 1. Since x is -6, z is 1. There we go. We will just solve this one. You know how to do that. It's basic math after this. Cross multiply will work. Y times -6 times 1 should be equal to 4 times -3 times -15 here. And divide both sides by just, -6 times 1, or the other way to say -6. That will be it. 4 times -3 times -15 over -6. I believe if you do the math, you will be able to get y is equal to -30. Okay, that's it. This is our formula. This is the proportion that we should create first, and basic math will yield us to a -30. Okay, that's how it is. This lesson will be easy, don't worry. Alright, page 488 still. Let's talk about the inverse variation this time. Remember how we have the direct variation, joint variation, that was k is equal to y over x. So we have the similar stuff. This time y varies inversely with x, so such that x times y this time will be equal to k. Or if you compare it from the previous one, y is equal to k over x is also fine, but it's better to stick to this one. X times y will be equal to k. If the two quantities are inversely related to each other, we will call it as x times y. Remember the direct variation, that was k equal to y over x. The idea is that one variable is increasing, let's say x is increasing, and this time y is decreasing, or x is decreasing, y is increasing. Okay, if we can see such relation, we'll call it inverse relation. Just like in this example, let's say we have 8 times 1, right? Like as 8 is x and 1 is y. So you can say it 4 times 2. You can say it 2 times 4. You can say it 1 times 8, like that. As you see, x numbers 8, 4, 2, 1, they are decreasing, the x values, but the y values, they are 1, 2, 4, and 8. It's increasing. So if we can create an inverse relation like that, That's basically inverse variation. X times y is equal to k is the format. Okay, or the same thing, if we have jointly variation, we'll just add the things around this one, but it's gonna come around the x times y is equal to k. Okay, example 3 on page 489. M varies inversely as n, right? So just like the formula we have here, we have xy, that means we should have k, I want to write the k first, m times n. That's what we should have. Alright, since again we are comparing the first and the second numbers, we should say m1 times n1, the first numbers of m and n, should be equal to m2 times n2. That's it. Alright, so as you see, the first number for m is -4, and the second number is 6. -4 times 6 should be equal to m, that what we are looking for, as the question says here, times -10, the second number of m. You know what to do, divide both sides by -10. That will give us the number, -10's cancelled. Here will be -4 times 6, -24, divided by -10, positive 2.4 will be the m in this inverse relation. Okay, so that's going to be our example 3. Example 4 still on the same page, 489. Suppose A varies directly as B and A also varies inversely as C. Okay, that's important. Looks like this is the first time we have direct and inverse variations together. That what you will see mostly in the exercises set. So we are doing it the same way. K, the constant. A varies, right? If it varies directly, remember how we say it should be A over B. And still the same, A varies inversely this time, as we said, it should be next to it like A times C here. Okay, when you say K is equal to the constant, the fixed, equal to A times C over B, inverse and direct. That's gonna be our formula. So in this case, A1 times C1 over B1 should be equal to A2 times C2 over B2. That's it. So let's read the question, the first part. Find B when A is 6 and C is 28. Okay, so A is 6. If you plug the formula, the first number of A is 6, the first number of C is 28, and we are looking for B. B or B1, doesn't matter how you write. O is equal to, when B is 7, A is -49 and C is 3. These are the second numbers of the variables. So A is -49, let's start with that. -49, that's -49 here. Let me write it. -49 times C is 3, so the second number of C is 3, and the B is 7 here. There we go. So we'll just do the math to see what it is. Cross multiply is the best as usual. 6 times 28 times 7 should be equal to B times -49 times 3. Since we are just looking for we are looking for B, we'll divide both sides by -49 times 3, like in this. -49 times 3. So the B should be equal to 6 times 28 times 7 over -49 times 3. If you do the math, if you use the calculator, you will see B here will be -8. So the B that we are looking for, the first number of the quantity B, it should be -8. Let's finish the lesson with a word problem. So, a rider's speed in miles per hour varies jointly with the revolution per minute. So we have speed here. We will represent it with by x. and the revolution per minute, RPM, right? We'll represent it with P, as you can see here. We'll represent this one with P. The pedals and the number of teeth on the front gear. The front gear is gonna be represented with F here, right here, and inversely with the number of teeth on the rear gear. That will be represented with R. Okay. One more time, the speed will be X, the revolution of the pedals will be P, F is the gear of the front, the number of the teeth on the front gear, and R will be the number of teeth on the rear gear. So if we create our formula, K as usual, since we start with X, let's create a reaction first. X is the speed, whereas jointly with revolution per minute. So jointly, right? Jointly is just the same with the directly. So X jointly or directly proportional with the P, the revolution of pedals. So that P should be right here, because when it is directly, we put it down here like X over Y, X over P here. And also jointly proportional with the number of teeth on the front gear, that's F, right? So we should have the F here. That means X is directly proportional with P and F here. And inversely with the number of teeth on the rear gear, that we call it R. Since it is inversely, the R should be here. One more time. X is directly proportional with P and F. That's why P and F here, bottom here, under X. And inversely with R, so R is next to X here. So X times R should be equal to P times F. That will be like X1 times R1 over P1 times F1 is equal to X2 R2 P2 and F2, like that. Okay, that's the deal. So we'll just put the numbers. Alright. Here we are. On a flat stretch of road, a rider is traveling at 17.1 miles per hour. So that means we start with a 17.1 mph, the speed. While using a front gear with 50 teeth, front rear, remember that's gonna be R, the F, so that will be a 50 here, that substitute with the F1 here. And a rear gear with 16. So the rear gear will be 16 since it is the inversely one, right? So it should be here, 16. And while we are doing this, that the pedaling, we are pedaling with a 70 revolutions per minute. So 70 will be here, replaced with the P1. Okay, should be equal to the next numbers. Find the speed. Looks like we are looking for the speed, the X2. So X2 or just X of the rider when she bikes uphill using a front gear of 34 teeth. So 34 is the front. We will have a 34 here. Times and a rear gear with 23, which is right here. That's R2, the rear. While pedaling with the same rate, that is 70 still. There you go. 17.1 times 16 over 70 times 50 should be equal to X times 23 over 70 times 34. If you do the cross multiplication, all that stuff, you're gonna see X here will be equal to, if you put these all together, 17.1 times 16 times 70 times 34. I just put them all together, the first side, this one, over the others. That 70 times 50 times 23. Since X is here, we just don't want it. We are looking for it. So the answer will be this one. If we put these all in the calculator, we are gonna get something 8.1 almost, if we round it to nearest tenth. That means the speed of the bike will be 8.1 miles per hour this time. Okay, so that's it. We just talk about the variations, direct, inverse, jointly, if it is direct variation, we say k is equal to y over x. Y and x represent the quantities, the variables, and the inverse one is k is equal to y times x. Okay, when you just use the formula, put the numbers correct spot and do the math, that will be it. Okay, so make sure you take these notes on the pages. Okay, and also try to check questions after each question. Like when you do example 1, do the check question after that. When we do the example 2 here, do the other check question, and so on like that. Okay, so I'm also giving the answers for these check questions. I would like to start with the first one, that is on page 488 on top. The first answer is for y2 is 10.5. So the other check question on the next page 489, that should be negative 0.5. And the check question on the bottom on the same page 489, M2 is negative 1.6. And the last check question on the bottom of page 490, part A, the proportion you should write first is k is equal to a times p over r, or the other way to say a1 times p1 over r1 is equal to a2 times p2 over r2. And for part B, the answer, when you plug the numbers correct spots, that should be 28. Okay, so that's it. That's the end of the lesson. Again, make sure you check the Google Classroom, your account, and see the homeworks. There is again Alex and the practice questions over there assigned. So if you will have any questions, you know what to do. Okay, I will see you next week about the next lesson.